Get my record going. Okay. So this is called graphs of sine, S-I-N-E. And we will probably not finish all of these notes today. So there will be. Okay. All right. And the target. This graph y equals sine of x and its variations next door. Yeah. Be able to identify the period. Amplitude. Domain. And range. Phase shift. And any vertical or horizontal stretches or shrinks. Did you take any? There are a lot of words to write in today's notes, and I do feel it's important because sometimes if you go back through and just like look at the graphs, you're like, how did she get that? I don't know what any of this means. So like I kind of think it's important to use the words to describe, what it is that we're doing. So when you go back and read it, you will know what we're doing without me having to tell you again. All right, because that's a lot of things in there that we have to figure out, right? All right, so trig functions can be graphed. In a rectangular coordinate system. By plotting points whose coordinates satisfy the function. We graph y equals sine at x by listing some key points on the graph. Because the period of the sine function is 2 pi, we will graph the function on the interval from 0 including 0 to 2 pi including 2 pi. The rest of the graph is made up of repetitions of this portion. You don't act like that in steps here either, do you? No. We're going to start with just a basic graph of y equals the sine of x. And then I'll show you how to graph variations of that, okay? So the most basic graph is what we're starting with. So we call it, I guess, the parent function. We will graph y equals sine of x. So it helps me a lot of times when I'm graphing these trig functions to just draw a unit circle and write the ordered pairs of the four main points, like 0, 1, or no, 1, 0, 0, 1, negative 1, 0, like, at like 0 degrees, 90 degrees, 180, 270, to just write those ordered pairs. That helps me. Y'all probably pick it up like that and don't need to write it every time. Me personally, I need to draw it every time. So I'm just going to draw a graph of a circle, unit circle. And we know at 0 radians, the ordered pair is 1, 0. At pi halves, the ordered pair is 0, 1. At pi, the ordered pair is negative 1, 0. At 3 halves pi, the ordered pair is 0, negative 1. And at 2 pi, the ordered pair is also 1, 0. Okay, so it's a little bit different than like your x coordinates and your y coordinates, okay? We are just graphing sine. Sine are the y coordinates, correct? So we're going to plot the key points at 0, at pi halves, pi, 3 halves pi, and 2 pi. 2 pi is what one interval is going to be made up of, okay? So a graph I'm going to go all the way to 2 pi. And then I'm going to split that area up into 4 equal sections. So to me, it's easy. It's like I'll mark like the halfway point and then split each of those into equal sections. So if one cycle is 2 pi, what's half of that? Pi, so that little halfway mark will be pi. What's a quarter of 2 pi? Or what you could say, what's half of pi? Pi halves. And what do you think that this little, what do you think that's going to be? 3 pi over 2, right? So the period is 2 pi. Period is like the horizontal length of a completed cycle, all right? So on the other axis, we are going to put what the possible sign could be, 0, 1, negative 1, and, I'm sorry, 0, 1, 0, and negative 1. Those are my signs, right? So it starts at 0, my highest is 1, the lowest is negative 1. So that's my sign. All right, so then I'm going to plot the points. So when at 0 radians, what is my sign at 0 radians? 0. Sign is your y value, right? At pi halves, what is sign at pi halves? 1. So at pi halves, will go up to 1. What is the sign at pi? 0. Back down to 0. What is the sign at 3 halves pi? Negative 1. What is the sign at 2 pi? Back to 0. So one revolution around the unit circle, if we were to graph that, That's what the graph would look like. And it just keeps repeating. So if we go 2 times around the unit circle, it's going to be the same pattern, just repeating over and over. Or if we would have gone clockwise around the unit circle, so we say, my angles are, or we go 0, blah, negative degrees, we go clockwise, it's negative. So if I go on the other side, same pattern over and over and over. So your sine graph, it starts at 0, 0. And you'll see when we graph cosine, it does not start at 0, 0. If we were doing cosine, what's the cosine at 0 radians? 1. So cosine would start up here. And this pattern is very similar. It's like that wave pattern. But where it starts, it's going to make a difference depending on if you're at sine or cosine. Okay? So we would say, in this case, that the period is 2 pi. And find a place to write down what a period is. Period is the horizontal length of one complete cycle. Horizontal length of one complete cycle. What do you think the domain is? So remember this, we've only graphed part of it, right? But what do you think the domain of, I told you, it keeps on going to the right, it keeps on going to the left. What do you think the domain is? Negative infinity to positive infinity. And those are parentheses because we never include, I didn't mean to put the plus sign. We can only put the minus, so I just changed it to a plus. We use parentheses because infinity or negative infinity is never included. What do you think the range is? Net, what we say, least equated. So -1 and -1 is included, right? -1 is part of the range. Up to +1 and +1 is included as well. Very good. Y'all know what the word amplitude means? Okay. Well, amplitude is the amount the graph travels above and below the midline. So where do you think the midline, what do you think that would be? Yeah, that's basically this axis, the horizontal axis, right? So how far does the graph travel above, how many units above, and how many units below? 1. So we would say that the amplitude is 1. I don't know why I put period down here and everything else up there. Let me write a little definition of amplitude as well. Amplitude is the amount the graph travels above or below the midline. Yes. It wouldn't. It'll always be the same number above and below if you graph it correctly. Okay, it wouldn't be different. But good question. And then just one more thing to note, and it talks about phase shift above and shrinks and stretches. When you have the most basic sine function, which is what we just graphed, we don't have those things, so we're not worried about that yet. Okay, but I do also want to note that the sine function is odd. We have odd and even functions. It's odd because the graph is symmetric with respect to the origin. Any graph that's symmetric, a lot of times you hear about the origin, that's called an odd function. Not because it's weird, because we have odd functions and even functions. So it's odd because it's symmetric about the origin. So my period is 2 pi. Period, remember, that's the length of one complete cycle. So if I just started at 0 and ended at 0, I did not complete one cycle, okay? One cycle basically is the one full revolution around. So how long is one complete cycle before the pattern starts over again, all right? So at 2 pi, then my pattern would start over again. A quarter of the way through, I'd go up to 1. Halfway through, I'd be back to 0. 3/4 of the way, I'd be down to -1. Or all the way through, I would be back up to 2 pi. Okay. So once it starts over again, that starts a whole new period. Coolio, not too bad so far, right? I feel like I say that every day with everything we do. Maybe I don't. Is everybody finished copying this? Okay. Now, a lot of words. We got a lot of words to write. But they're important words. So I have a little title here. I'm going to call this Graphing Variations of Y equals Sine of X. Okay. To graph variations of Y equals Sine of X by hand, it is helpful to find x-intercepts maximum points and minimum points. One complete cycle of the sine curve includes 3 x-intercepts one maximum point and one minimum point. When graphing the sine function, the curve reaches its maximum point one-quarter of the way through the period, and its minimum point 3/4 of the way through the period. It's best to divide the graph into 4 equal parts. Almost finished. One more bullet point. The graph of Y equals Sine of X forms the basis of the form y equals a times the sine at x. All right, so let's do example 2. We are going to graph y equals 2 times the sine at x. So, like I said before, I usually like to draw. We don't need a giant unit circle, just a small unit circle. I like just to label all the points like a quarter of the way around, halfway around, 3/4 of the way around. So we know 0 radians, the ordered pair is 1 comma 0. At pi halves, the ordered pair is 0 comma 1. At pi, the ordered pair is negative 1 comma 0. At 3/2 pi, the ordered pair is 0 comma negative 1. And at 2 pi, the ordered pair is also 1 comma 0. Now we're going to want to make a table of values. And I'm going to show you how to solve some of these simple trig equations. Okay, they're going to get more difficult, but not today. Today they'll be pretty simple. And we're going to substitute in values for x at when you have at 0 radians, at pi halves radians, at pi radians, at 3/2 pi radians, and at 2 pi. And I'm also going to get my holograph set up over here. Well, no, let's find ordered pairs first, because I don't know how high or low I'm going to need to go until I find these ordered pairs. I don't know what my amplitude is going to be. Okay, so let's do that afterwards. Okay, so let's start at 0 radians. So I want to know, what I'm finding is, what is 2 times the sine at 0? All right, so we are finding y at 2 times the sine at 0. So find the sine at 0 first before you multiply by 2. What is the sine at 0? 0, because remember sine's your y value. So that's y equals 2 times 0. The sine at 0 is 0, and then 2 times 0 is 0. So that's going to be the first ordered pair we graph, 0, 0. Now let's find y equals 2 times the sine at pi halves. Well, what's my sine at pi halves? 1. So that would be 2 times 1, because the sine at pi halves is 1. What do we get? 2. So we're going to graph that ordered pair at pi halves. We are at 2. Same thing for pi. Y equals 2 times the sine at pi. Sine at pi is what? 0. So 2 times 0 is 0. I'm going to stop for a minute at home, though. It's lagging. I haven't done a pi yet, so I'm going to give it a second. But y'all can see the trend, so you can keep on looking. Like. Okay, at 3/2 pi. Y equals 2 times the sine at 3/2 pi. What's the sine at 3/2 pi? Negative 1. So 2 times negative 1 is negative 2. And the last one is 2 pi. Y equals 2 times the sine at 2 pi. What's the sine at 2 pi? Negative 1, right? It's your y value. So y equals 2 times negative 1. Y equals negative 2. So what do you think my amplitude is going to be? What's the highest I'm going to go up and the lowest I'm going to go down? How many units? 2, right? So I'm going to go up a maximum 2 and down, I'm going to go down 2 as well. So I know that on that, I guess you would say, on the vertical axis, on last time I just went up to 1 and then down to -1. I'll need to go up to 2 and then down to -2. You think I might be able to tell that by the equation that was given to me? I mean, everything was multiplied by 2, right? So I wonder if that has something to do with that. So I make my graph. I go all the way up to 1 cycle, which is at 2 pi, and then I divide that in half, which we know that half is pi. And then half of pi is pi halves, and then that other mark between pi and 2 pi is 3/2 pi. Everybody cool so far? So when x is 0, we found out y is 0. When x is pi halves, y is 2. When x is pi, y is 0. When x is 3/2 pi, y is -2. And at 2 pi, when x is 2 pi, y is, I might almost spoke. Oh, look what I did. Notice tell me. Should be 0. See right there, like I know what the graph is supposed to look like. So at that point when I'm like, wait, would it also be at -2? I was supposed to make it go straight from the last point. That would let me know I made a mistake, right? So then I can see over here, I said the sine at 2 pi was -1. I don't know where I got that from. The sine at 2 pi is definitely 0. So let's fix that. And then 2 times 0 is 0. Y'all know I make mistakes. You can tell me. Even if you're not right, it's okay, but there's a good chance you probably are. Okay, so when x is 2 pi, y is 0. And again, this is just one cycle. This pattern keeps on going. We could go around the circle again and again, or we could go clockwise around the circle, clockwise around the circle. This is just one cycle, okay? So how long is the period? Two pi. Remember, period is the length of the horizontal length of one cycle. What would we say the amplitude is? 2. Amplitude is the distance above and below the midline. What do you think the domain is? Yep, negative infinity to positive infinity. What do you think the range is? -2 to +2, do least to greatest. So is -2 included? Is it part of the range? Yes, so we use a bracket. All the way to +2. Is +2 included? Yes, we'll use a bracket. And we don't know this yet. We're going to write the definition on the next page. But if a is greater than 1, the absolute value of a is greater than 1, which a was the number that's being multiplied up here, the 2. If it's greater than 1, we say that we have a vertical stretch by a factor of whatever the absolute value of a is, okay? So we'll write the definitions on the next page. But we're going to say this is a vertical stretch. So it's a stretch compared to what the parent function was, okay? Vertical stretch by a factor of 2. Everybody cool? Okay. Next page. This is my page 3. Like I said, we were going to write the definition or how you know if it's a stretch or a shrink vertically. So if the absolute value of a is greater than 1, then we say the sine curve is a vertical stretch. If the absolute value of a is less than 1, then we say the curve is a vertical shrink. And now we're going to do example 3. Which says to graph y equals 1/2, bless you, times the sine of x for values of x that are between 0 and 2 pi inclusive. Which that's what we've been doing, but we've been graphing between 0 and 2 pi. But if it said between 0 and 4 pi, how many cycles would that be? 2. If it said between 0 and 6 pi, how many cycles would that be? 3. So this is still the same as what we've been doing, but that could change. They could want more than one cycle. Okay, no big deal. We'll do the same thing we've been doing. So, of course, I'm going to draw a little circle. And this also helps you memorize. Like, if I say, hey guys, what's the sine at pi halves? You can say quickly, oh, it's the sine at pi halves is 1 without having to draw the circle in your head. I probably still have to draw the circle in my mind. But I've told you before that everything I know about query I have to teach myself. And so I have to think about things because my older brain does not absorb things as well as your younger brains. So a lot of times when you're like, why should you keep doing it over and over and over? Like, we got this. That's probably why. Because to me, I just have to make it work in my head right. And I'm going to make a table of values to help me find these ordered pairs. Same x values of what we've been doing because we're only going from 0 to 2 pi, just one period. We'll try to get this one done before the lunch bell rings so that this video will include the whole problem. And if you're watching from home, not from my 5th period class, but from my 2nd period class, 2nd period you would probably, but 5th period was, so we're going to break it. All right, so I'm pretty sure y'all can do this on your own, so I'm going to go fairly quickly. So I'm going to start at 0. So y equals 1/2 times the sine at 0, substituting in 0 for x. What is the sine at 0? 0. So what's 1/2 times 0? 0. So order pair 0, 0. Now go to pi halves. Y equals 1/2 times the sine at pi halves. The sine at pi halves is what? So y equals half of 1. What's half of 1? 1/2. Now go to pi. Y equals 1/2 times the sine at pi. What's the sine at pi? So 1/2 times 0 equals 0. See 3/2 pi. Y equals 1/2 times the sine at 3/2 pi. And the sine at 3/2 pi is -1. So what's half of -1? Negative 1/2. Very good. And what do you think the sine of 2 pi is going to be when we multiply it all out? Or 1/2 times the sine of 2 pi? 0. Because the sine at 2 pi is 0. So 1/2 times 0 is 0. So what's my amplitude going to be? 1/2. So on my graph, the y-axis, I only have to go as high as 1/2 and as low as negative 1/2, right? The x-axis, where we put our radian measures, the same as we've been doing, and the same as what we have to take. You won't need me for this, I don't think. So I'll just do it quietly. So what is our period in this case? 2 pi. What is the amplitude, which we already said earlier was what? 1/2. Would this be a vertical stretch or a vertical shrink? It's a shrink because the absolute value of A is less than 1. So we're going to say it's a vertical shrink by a factor of what? 1/2. So that basically means your amplitude is half of what it was in your parent function. On the last one, your amplitude was 2. It was a vertical stretch by a factor of 2. Your amplitude was twice the amount of what it was in the parent function. And what is the domain? Negative infinity to positive infinity. And how about the range? Negative 1/2 to positive 1/2, and those would be brackets, not parentheses, because they're both included. Now tomorrow, we're going to pick up and graph y equals 3 times the sine of x. Y'all think you could do that on your own? Totes, right? Yeah, so that's where we'll pick up tomorrow. So today, there is no assignment. So make sure your notes are all looking good and complete and what have you. Make sure you turned any assignment from yesterday. And then tomorrow, we'll finish up these notes. Julio? At home, once you've got everything copied, you can